Hello, this is Richard Walker from Lucidate. Welcome to this video series on decentralized finance. In this series, we're going to examine the Ethereum blockchain. These videos will assume that you understand the basics of cryptography, cryptocurrencies, and blockchain, that you're familiar with private and public key encryption, that you're comfortable with the concepts of hashing algorithms and have a feel for distributed ledgers along with their consensus mechanisms such as proof of work and longest chain. If these terms are unfamiliar to you, then don't worry. Lucidate has a separate video course which serves as an introduction to cryptocurrencies. In that series, we walk through Satoshi Nakamoto's Bitcoin paper and introduce all the concepts mentioned earlier. There's a link in the description for this introductory course. The following videos in this collection will discuss the following topics: smart contracts, the foundational blocks of DeFi, building and deploying your own cryptocurrency, an introduction to NFTs, non-fungible tokens, along with full instructions and a code template to allow you to build and deploy your own, bonds and microfinancing. In the remainder of this video, we will address the key points of difference between Ethereum and Bitcoin. These will include 1. Extensibility, smart contracts versus unlocking scripts. 2. Equity and enforcement, gas fees versus mining incentives. 3. Efficient consensus, proof of stake versus proof of work. Don't worry for now if these terms are unfamiliar. They will be explained later. Ethereum uses much of the same foundations as Bitcoin. It uses a distributed ledger. It makes use of public and private key cryptography and hashing as a mechanism to provide trustless proof on the blockchain. And, like Bitcoin, it is decentralized. No single node or entity holds sway over the network. A crucial difference between Bitcoin and Ethereum is Ethereum's use of smart contracts. This is what allows Ethereum to be extended beyond an alternative payment system to being a fully fledged development environment for deploying applications. These decentralized applications, or dApps, are what powers much of the DeFi ecosystem. When discussing Bitcoin in our introductory videos, we made the casual statement that a message was written to the ledger. It's now time to be more specific about what that message is. That message is Bitcoin Code. Bitcoin Code is a type of language called Turing incomplete. Among other things, this means that Bitcoin Code can't have loops. Now, this was a deliberate choice. If a malicious actor or poor programmer deployed some code with an infinite loop, then all nodes would get stuck executing this code and the network would be brought down. But without loops, a line of code either executes successfully or it fails. Thus, being Turing incomplete was a deliberate design choice, not an omission. Bitcoin Code does incorporate validation, equivalence checking, and mathematics. The table on your screen shows some of the most common operations. The most common type of transaction in Bitcoin is to reassign a UTXO by providing your private key. This looks something like the code on your screen. Now, naturally, to use Bitcoin as a currency, you don't need to know any of this. All of this is handled under the covers by your wallet. But the messages I spoke of glibly in earlier videos are a little more functional than simply being glib messages. They're scripts of executable cryptographic code. Ethereum builds further on this concept. Instead of using a simple scripting language, it uses Solidity. This is a Turing complete language with loops, events, classes, data structures, mappings, user-defined functions, and a whole host of other features found in fully fledged programming languages such as Java and Python. We'll discuss Solidity and smart contracts more in the next video, but for now, understand that a key difference between Bitcoin and Ethereum is that Bitcoin is purpose-built for transferring ownership of digital coins in a trustless environment, whereas Ethereum is a development environment complete with its own development language, Solidity, for developing DeFi apps on a trustless, decentralized network. Bitcoin is a payments network. Think of Visa or MasterCard. Ethereum is a global computer. Think Amazon Web Services or Microsoft Azure. Thus, the Ethereum blockchain can be considered as made up of two key elements. Firstly, a global computer comprised of a set of decentralized nodes. Secondly, an immutable ledger of Turing complete executable contracts. Now, in opting for a Turing complete ledger, Ethereum creates two major problems for which there is fortunately a common solution. The first problem is who pays? Who pays for the building and running of the network? The second problem is how to address the infinite loop issue of a Turing complete language. The answer to both these problems is gas. Think of gas as gasoline. Gas is the fuel for the Ethereum network. Every operation consumes resources. This might be a simple operation like storing a small integer on the ledger, or it may be a complex operation involving the interaction of many smart contracts. Simple operations consume a small amount of Ethereum gas. Appendix G, perhaps for gas, of the Ethereum technical specification lays out the differing gas costs for different operations. Currently, addition costs 3 units of Ethereum gas and multiplication costs 5. As we're talking about gasoline, an automobile analogy is perhaps helpful. 1, the amount of computation matters, analogous to distance driven in a car. If you drive your car from San Francisco to Los Angeles, you will use less gas than a trip from San Francisco to New York. 2, efficiency of computation matters. If you take the trip in a Hummer, you will use more gas than if you drive a Prius. 3, tax is an effective way to pay for shared resources. Much as gasoline can be taxed to pay for road development and maintenance, Ethereum gas can compensate providers of compute resources on the blockchain. The use of gas also solves the Turing complete infinite loop problem. Not only does it incentivize good programming and penalize bad actors, but there's also a gas limit per block. Currently, the limit is 30 million gas. See the URL on your screen. This means that if a miner includes a rogue transaction with an infinite loop in a block, then this transaction will attempt to run indefinitely, as there is no way it can terminate on its own. Eventually, though, it will consume the gas limit. Then it can be marked as a failed transaction, and any changes it made to the ledger state will be reverted. The final major difference between Bitcoin and Ethereum is the validation and consensus mechanism. You may recall that Bitcoin secures each block by requiring that miners compete to be the first to solve a cryptographic guessing game. This requires that they invest large amounts of fiat currency to build huge mining farms and power them with vast amounts of electricity. Ethereum is changing its consensus mechanism to proof of stake. This is currently scheduled for the second half of 2022. By the time you are watching this video, that change, called the merge, may already have occurred. In contrast to proof of work, proof of stake simply requires that validators stake Ether. A validator is chosen at random to validate the block, and if it turns out that they've acted fraudulently, then their staked ether may be slashed. In essence, both staking and mining require large capital investments to participate, but only mining requires large amounts of energy. So in conclusion, Ethereum takes the core concepts of Bitcoin, a public distributed ledger, and some clever ideas from cryptography to build proof and consensus. On top of that, it adds a Turing complete language. Not only does this allow for the transfer of cryptographic currencies between accounts, but it also allows for much more complex financial contracts and interactions, as we'll see in future videos in this series. In order to pay for shared resources and to guard against abuse or bugs resulting from infinite loops, Ethereum has a policy of Ethereum Gas. Gas is a micropayment that compensates providers of shared resources. Gas limits on blocks ensure that offending transactions and contracts can be unwound and removed from the pool. Finally, the proof-of-stake consensus mechanism allows for greater scalability, security, and energy efficiency. This is Richard Walker from Lucidate. Thanks for watching. Please join me in the next video where we take a closer look at Solidity and smart contracts.